Okay, well, welcome back. Um, this is our third and final video in this series of solving double angle formulas. And what you might want to do, just when you're doing any video, is if you want to try this at home, you can actually write this down and then solve it for yourself. Okay, pause it and then come back and see what the solution is and if you need to work it out. And if you get stuck, pause it at any time and see if you can work it out before you get to that. That's a good study tip for anybody that's using any of my videos or anybody else's videos when you're doing some little studying or reviewing for tests or whatnot. So, in any case, let's solve this problem. What we have right here is cosine of 2x minus cosine of x minus or equaling 0. Uh, we could probably maybe do this two different ways. However, we're going to use a double angle formula to help us out because once again, we realize that we have a b here that equals 1, and we have a b here which equals 2. Doesn't really mix very well in solving this, so we're going to use one of these over here with cosine of 2 theta. Now, in order to figure this one out, we're going to take, and we see we have a cosine here. And because it's cosine, notice we have several different options. Cosine squared of theta minus sine squared of theta equals cosine 2 theta. If we change this and use a trig identity, because if you recall, sine squared theta is 1 minus cosine squared, we can actually simplify this to 2 cosine squared of theta minus 1. If you want to make this in a sine, we could change this and use a trig identity into this formula. So using trig identities, we have 1, 2, 3 different options. How do you pick which option to use? Well, depending on what is left over here. Because this is cosine, we want everything in terms of cosine, so we're going to use this portion right there. If it was sine, we'd use that one, and so on and so forth. So we're going to use a little substitution. I'm going to plug in 2 cosine squared of x, in this case, minus 1 in there, minus cosine of x, and that's going to equal 0. From here, what I've now created is a trigonometric equation, or sorry, a quadratic equation, I apologize. And we can then use a little bit of algebra. It's a little bit harder, you probably know. So if you did pause this and got stuck, I totally get it. Okay. Now from here, we can kind of see this being, okay, if this were 2y squared minus y minus 1 equaling 0, how would we factor this? We have 2y's. It would probably be a plus y, and then we would have a plus y, plus 1 here. I'm just doing some algebra on the side, and then we would have y minus 1 there. We can check it out, see if this works out. Y 2y squared, and then we have right here is going to be negative y, and then negative 1. Yep, and so what we have then is, since instead of using y is actually equal to cosine of x, we're actually going to have a solution of 2 cosine of x plus 1. And that's going to be cosine of x minus 1 equaling 0, if that we said right there. So noticing that we have cosine squared and cosine, we can kind of rewrite it like this. This is in my previous videos of how to use quadratics when solving. Okay. Once again, algebra. If you forgot this, you might want to review how to solve when you have quadratics. From here, now we're just going to solve this. We're trying to find all the solutions. We're going to find all solutions. My other videos I had where we find from 0 to pi, but we'll do all solutions in this case. And so we can now, because it's equal to 0, we can make this 2 cosine of x plus 1 equals 0. And then over here, we can use cosine of x minus 1 and set that equal to 0. I'll do this one because it seems a little bit easier first. So we have 1 right there. And when is cosine of x equaling 1? Well, cosine of x equals 1 at 0. Okay, and every 2 pi, because if you go around here at pi, remember it's going to be negative 1, 0. And over here at 0 degrees, it's 1, 0. So essentially, we're looking at x equaling 0 plus and minus 2 pi n for all the solutions. Or if you just want to put 2 pi n plus or minus 2 pi n, that would also be correct for all the solutions of x. Over here, we're going to have cosine of x equaling minus 1 over 2. And if you draw your little grid right there, you can see that when it's cosine is negative in the second and third quadrant. We have -1 and 2 here. Well, what is that angle? Well, that's going to be this is a right angle 3, and this is going to be negative right angle 3, 2. That angle, reference angle, is going to be a 60-degree angle, or pi over 3. And so we have our answer is going to equal x equaling, well, second quadrant, 2 pi's over 3, plus or minus, because we're looking for all solutions, plus or minus 2 pi n. And then here we're going to have x equaling third quadrant. So this is our second quadrant. And going all the way around, we're going to have the other one going to equal 4 pi's over 3 plus or minus 2 pi n. And that is going to be all of our solutions for x. So these are all solutions for x. Okay, that we have. All right, that's it. So once again, a little bit tougher. Doing double angle formula for cosine, we know we have 3 options here. 3 options, okay? Depending on what we're given there, we're going to pick the correct option. Since we have cosine, we're going to use the cosine. If we had sine, we would use that one. If we had both of them, we probably would use that, both cosine squared minus sine squared. And then going through, if we have that, we're going to use some quadratics in solving, but then it just goes in just as simple solving equations that you learned hopefully back in the day. Okay, so I hope this helps you out with your homework and your quizzes or tests or whatever review you have. I'm going to have some other videos and just simplifying that with using the double angle formulas in some upcoming videos. All right, so good luck and God bless.